In this screencast, I'll be showing you a simple backdoor that can be used to reset the password of any Windows account on virtually any version of Windows. However, before we get started, I need to mention two very important disclaimers. The first is that you should only use these techniques to access computers that you have a lawful right to access. So I'm not condoning tampering with computers that you do not have the right to be accessing, and I do not intend this tutorial to be used for those purposes. Secondly, if you lose data, destroy your computer, make anyone angry, disrupt your day, give yourself a headache, or otherwise have bad things happen because of this tutorial, it's entirely your fault. So follow these instructions at your own risk. With that out of the way, let's define some terms. This method for resetting Windows passwords through a backdoor will perform a password reset. The nomenclature of the term password reset implies something a little different than just a password change. A password reset can be disruptive. Resets do not perform any additional operations like changing the encryption keys that are associated with the user account, and we're going to find that out here shortly. You should also know that this operation is not a crack. This is not a password recovery. You're not going to be able to see the user account's old password. There are entirely different methods for seeking to uncover an account's password, but this tutorial doesn't touch on any of those. This method simply resets the account's current password to a new password of your choosing, and you will never see what the old password was. So now that you understand what this method will and will not do, let's discuss a little bit about how we're going to be doing it. First off, physical access is a must. Now that can be through physically touching the machine or a KVM over IP device with remote media. Remote media is important. This is not a method to reset a password over a network. So this won't work if you only have remote console access through, say, VNC, RDP, or some other remote access tool like BombGuard or TeamViewer. The whole method hinges on having physical access to the PC because ultimately the goal of this technique is to acquire unencrypted offline access to the Windows System32 folder and rename a single executable file within that folder. You can use any number of methods to do this, including slaving the drive to another PC and browsing the file system, using a Windows installation disk, using any other bootable media, really, that can interact reliably with the NTFS file system. So for instance, a Linux Live image on a CD or USB drive. You could use a recovery partition like you might find on a consumer PC. Whatever you do, it really doesn't matter as long as you have unencrypted access to the System32 folder while the Windows instance itself is not running, because it won't let you rename anything within System32 if it's running. So now would be a good time to mention that if someone has physical access to a computer and is intent on doing mischief, they pretty much own that computer in question. So keep your physical assets safe. And that's actually where drive encryption can really help you out. If it's the right kind, there's different kinds and different levels of encryption, and not just encryption key strength, but also methods such as volume versus disk encryption. And that's a little bit outside the scope of this video. Now notice how I said you need unencrypted offline access to the System32 folder. That's because if you're trying to perform this method for resetting a password on a Windows machine, drive encryption is going to ruin it for you if the boot volume is encrypted. That's actually pretty rare though, so you probably don't have to worry about it. That's the breakdown. We need physical access to the computer and offline unencrypted access to the Windows System32 folder. So let's move to our victim PC. This PC is running Windows 7 Professional. Let's show you right here. Windows 7 Professional, Service Pack 1. I'm logged in right now, and of course I know the password to this account. So I'm going to set the password to something random, kind of off the cuff. I'll just hammer on the keyboard here. So there's no way that I can possibly remember that, at least not with my memory. So let's go set the password to this complex one. And there we go. We've set our password. So let me now draw your attention to this folder on the desktop here. This is encrypted with EFS. Let me prove it to you. Encrypt contents to secure data is selected. There's a visual indicator within a folder. Notice that all the file names are in green. Notice that these files themselves are also encrypted. Notice that I can see inside these files. So I am going to log out and we're going to get going with the password reset demonstration. However, before I do, let me set the stage for a demonstration of how Windows handles EFS and why this is actually going to be important anytime you reset a password using this method. EFS stands for Encrypting File System and is a technology within Windows that allows users to easily protect their files with encryption. Now the following information that you see here is taken from technet.microsoft.com, and a link to this specific article is in the notes below the video if you're watching it on YouTube or Vimeo. I won't read it all, but what this means in a nutshell is that EFS keys are protected by each user's account password. So if you lose your account password, you lose access to any files protected by EFS. EFS is performed at the file system level, basically within NTFS itself. So applications have no clue about it. They don't have any role to play in the encryption of the files that they're writing to disk. EFS encrypted files can only be unencrypted through the key pair that is itself encrypted using your account password. Properly changing your password will change the encryption keys, and thus you're not going to lose access to your EFS encrypted files. A proper password change is done through the control panel or by pressing Ctrl-Alt-Delete and changing your password from the option presented to you there. Resetting a password using the method that we're about to use is not going to update the EFS key pair, and thus you will lose access to any data that's encrypted using EFS. And of course there are caveats to the danger of losing access to your data, and those involve setting up designated recovery agents before any password resets are performed, but those topics are beyond the scope of this screencast. And if those sound of interest to you and your situation, then I advise you to Google that. Let's get back to our victim PC. So now that I've explained all that to you, it's time to log off. At this point, after all of that talk about EFS, I have no recollection of what that password is that we changed. So I can't get back in. So I've pretty much locked myself out of this PC. Take a look down in the lower left corner of the login page. You see this little icon? That's the accessibility options icon, and probably not a lot of people have ever looked at it or even noticed it was there, or if they did, they probably never clicked on it. When we press it, we see that we have various options to launch some basic accessibility utilities. For example, we have the on-screen keyboard here, which is helpful if we have a tablet or some kind of touch screen. What you don't see is that the executables that are launched from the accessibility options tool down there in the lower left-hand corner, they're all running as the system user. The system user is basically the granddaddy of all Windows users. So we have the on-screen keyboard running right now as the most powerful user on this computer. This is the most powerful on-screen keyboard you will ever see. Now is when our boot disk comes into play, or any of the other offline access methods that were listed earlier in this video, such as a bootable USB drive or a recovery partition. I'm going to be using a Windows installation disk to gain offline access to this hard drive. In fact, I'm going to go old school just for kicks, and I'm going to use a Windows 2000 Server CD. So let's boot into that. Boy, that brings back memories. I'm going to skim over the options that I choose here. It's just the standard options that you would choose to get into the Windows Recovery Console on an older version of Windows. It's going to get us into a command prompt where we can make a few changes to the underlying file system on the hard drive. So this part really isn't that important. So let's move to the System32 folder. Now I happen to know that the on-screen keyboard's executable is osk.exe. And there you see it. I also know that, of course, the command prompt is cmd.exe. So what would happen if we simply renamed cmd.exe to osk.exe? Let's find out. And it's as simple as that. So let's reboot. So now we're back at the login screen. And of course, I still can't log in. Don't remember the password. Let's see if the on-screen keyboard will help us. That is a funny looking on-screen keyboard. Even more importantly, look at that. I am the system user. At this point, it's just a matter of changing passwords using good old net user. And that's my password, by the way. Let me in. Now notice there's no smoke and mirrors here. This is a 7-character password. And if you remember, the password that we reset it to, that big long junk password was, well, it was more than 7 characters. And look at that. We now have access to the account that we locked ourselves out of earlier. Now notice the command prompt is still up. It stays with you. But notice that I am now the user account rather than the system account. Now we could have just as easily done this to add a user instead of modifying an existing user's password. For example, we could have gone and of course I'm denied because I'm not at an elevated command prompt. But the idea is if you wanted to add a user rather than tamper with an existing user, that's just another option. Now if we had created a new user, we wouldn't have to worry about losing access to any EFS encrypted files, like for instance these. We can open up the folder, but notice we can't get to any of these files. Access is denied. Now I might seem kind of hopeless at this point, but I've found that if you reset your password back to what it was previously, or back to what it was the last time you did a proper password reset, you can access those EFS encrypted files again. So let's reset the password back to the complex one that we had set before, which is this one. Current password is let me in. I'm going to paste the new old password in, the one that we reset. You'd think that we'd at least have to log off and log back on again to be able to access these EFS encrypted files. But in fact, we don't. So there we are. We can access the EFS encrypted files once we've set the password back to what it was the last time it was properly set. And that's a good point. Keep in mind that we could have reset this password hard like this using this little backdoor method a dozen times over the course of a month. And we'd still have to go back to the last password that was changed gracefully, which in our case was this one right here. And that is how you defeat account security in Windows if you have physical access to the PC and unencrypted offline access to the System32 folder. Don't forget to go back and rename the command prompt that we named to osk.exe, and of course you're going to want to rename osk.exe back to its original name if you want that. because otherwise you have this gaping security hole just sitting there waiting for someone to use it. If you found this video to be useful and you watched it on YouTube, please like it with the thumbs up button and subscribe to see more videos. If you watch this on Vimeo, please like it with the heart button and subscribe to my video uploads. Check the notes below these videos if you're watching them on YouTube or Vimeo for some more information and cool links. Feel free to share this video or embed it anywhere that you think people would appreciate it. Thanks for watching.